So the argument is going to be, okay, so you see what we did. We would like to find out what is going to be the position. Suppose, you know, I give you your grade of this test. So what you are going to be interested in, you want to know what is your position in the class, if you like. Okay, what are going to be your position with respect to the other people. We're going to talk about the Z score. And Z score just give you the number of the standard deviation that your grade is going to be above or below the below the mean. So what we're going to do, there is another tool to identify the position of any value. And this tool is going to be called percentiles. Okay, it's different from percent. So what we are going to do, we are going to get you see, the idea is going to be, if this is going to be a number line, I divide this number line into the 100%, then I throw the numbers, the grades of the class over here. So we give a ranking for your grade. So this ranking is going to be the percentile. So if your rank, your grade rank is going to be, for example, 85, so this means your grade is better than the grade of 85% in this class. And there are 15% grades that's going to be above you. So this is the idea that we're going to do. Okay, let me just give you the definition and just identify what is going to be the application of this idea. Okay, so we are still in that section 3.3. This is the second part because we did something for you already. Okay, that was the Z score, and this is something else. I'm just checking to see if I can get my red. Yes, this is it. So the idea is called percentiles. Okay, what's going to be percentiles? Okay, and new measurements in order to locate your number. So what's going to be a percentile? Percentiles are going to be used. Okay, percentiles are used for our purposes, locating the data values. Percentiles are used to what? To locate your grade, to locate the position. Okay, locate the position of a data value. Data value in the given data set. Okay, the ranking of your grade in this class. That's going to be the percentile. Now you see, if we say that if this is going to be the number line, and if we are telling you that, and this is going to be your grade. Okay, this is going to be your grade X. If you say that your grade X is in the ranking of the 80th percentile, you see if this is given to you. So this means that you are better than, you see, this means the number of the values, the grades that are going to be below you is 80%. That's going to be 80%. And the complement is going to be 20%. So this complement is going to be 20%. So this means your grade is, okay, your grade is greater than, if you like, the grade of 80% of the population of the class, and it's going to be less than 20% of the population of the class. Okay, so it's going to be a special ranking. It's like, you know, when you read your credit report, they say your credit score is, okay, for example, 735. Then they explain it for you that you are better than, you know, 35% of the population of all the people, okay, or in America. And so this is, so for example, I explained this example for you. because you have some problem in your book that they ask you just to explain the meaning. So for example, if a value x, if a value x is said to be is located, okay, if it's going to be located at the ranking of at the 18th percentile. Okay, if this is going to be the case, what does it mean? So this means, so it simply means, okay, it means that 80% of the values, 80% of the values are or fall below your number, below the value x, below the value x, and in the distribution, if you like, the distribution of those grades, and 20% are going to be above of the values. Values fall above it, or let's say fall above the data value x, the data value x. Okay, so this is the situation that we are going to have. And so we are going to have a special notation for this ranking. So the kth percentile, okay, the second, the third, the 20th, etc. Percentile is going to be denoted, is denoted by P sub k. So if you say P sub k, you know, P50 is equal to the 80. And so this means the ranking of your grade, 80 is going to be 50 here, okay? So that denoted by PK. So the K percentile is denoted by PK of, I explain it again, of data set is going to be, so this is going to be, is a value x such that, again, K% of the numbers are going to be below K% of the observations, K% of the observations are less than, okay, are going to be less than x. In some books, they say less than or equal. It doesn't matter. We go with the less. Are less than, okay, less than x, and the complement 100 minus K% are going to be greater than x. Okay, that's exactly what I describe it for you. Okay, any question? So if you like it, this is what we do really. This is the number line. Okay, so what we're going to do, this is going to be number line, and this is going to be 0 if you like, and this is going to be kind of 100%. So what you are going to do, you are going to divide it into ones if you like. You say this is going to be 1%, the 1%. So if your grade is going to be here, this is going to be P1. So P1 means it's only better than 1%. Okay, then you are going to have another 1% here. So 1% and 1% would be 2%, so this would be P2. Then you get the other one that give you P3, and you can continue. You can continue. The most that you can have is going to be P of 99. Okay, so just divide them into the different bits. Okay, so these are going to be the values that we're going to have. So in that case, and now there are 3 special cases that we are going to be very much interested in. You see, what we do usually, we divide this one into 4 parts. So get it again. Divide it into 4 parts. So this is going to be 1, 2, 3, and 4. Since the total is 100%, so each part is going to be 25%. Okay, so this is going to be 25%. Another 25% make this one to the 50%. And that gives you 75%. 75%. So in this area, the number that it's going to be, we call it P25. P25 means you are better than the 25%. If you are going to be here, you are going to be P50. And if you are going to be here, you are going to be P75. Since we divide into 4, each section is going to be called a quartile. Quartile. This is going to be the first quartile. This is the second quartile. And this is going to be the third one. We are going to use them. You must know them by name. So this is in particular, when you talk about P25, we have a special notation for it. In your calculator, if you want to do these type of ideas, it's going to be denoted by Q1. So if we say Q1, you must know that the Q1 is P25. Okay, Q1 is a P25. It's going to be the values. It's going to be better than 25% of the other. This is going to be called first. Okay, first quartile. So you must know them by name. Okay, Q1 or first quartile, P25. Q2 would be P50. P50, you are in the middle. So if your grade is going to be at P50 means you are better than, exactly better than 50%. And there are 50% of the values to your right and 50% to your left. Okay, this is going to be called a second. Okay, second quartile. There is another name for it. Any suggestion? If your number is going to be on the number line so that there are 50% of the values to your left and 50% of the values to your right, what is your number? It's another name for it.
Median?
Excellent, yes, median. So second quartile or median. Because this is 50% to the right, 50% to the left, okay? Or median. Okay, any question? And we introduce Q3, which is going to be P75. P75 is going to be third quartile, okay? So it's going to be third quartile. We're going to have a couple of more problems or concepts that would depend on the Q1, Q2, and Q3. So we don't usually use P25, P50, P75. You can use if you like, but we refer to it as the Q1, Q2, and the Q3. If you do with your calculator, the calculator give you Q2. The way we did it the other day, remember, for the mean and the standard deviation, at the same time, the calculator will give you the Q1, Q2, and the Q3. And it's not a big deal. You'll see in a minute. that there is a shortcut that we can find them, and you don't need any calculator for this one. Okay, any question? Now, what's going to be your job? You see, you have two problems to solve for us. The first problem is we give a data set, the grade of this class. We give you the value and we ask you for the rank, percentile. Okay, you got 83 in this class, result of your test one. We want to know what's going to be your ranking. The ranking would be the K that I define here. So a value would be given, you identify the percentile. That's the first problem. The second problem is the other way around. The ranking would be given, you have to give us the numbers. Okay, let's make it into the one problem, two parts for your next, next quiz. So I'm going to show how I'm going to do it. Okay, any question? Are you ready? Checking the first problem. So the first problem that we have to solve is this one, finding. Okay, the first problem is finding the percentile of a given number, finding the percentile, okay, percentile K if you like, of a given data value X. So a number would be given, you want to find the percentile. It's going to be a kind of percent, okay, but this is how we're going to do it. We give a formula, then you apply this formula to get the result. Okay, there you are. This is it. In order to find the percentile. Okay, the percentile of a given value X, you are going to use the following. Easy formula. The formula is K, which is going to be percentile of percentile. Okay, the percentile of X. Percentile of X is going to be equal to, this is going to be equal to, you are going to list the given information, okay, order the values from the smaller one to the bigger one. Then you are going to check how many numbers, how many values are going to be less than X. Okay, so on the top is going to be, you see, this is going to be number of values, number of the values which are going to be less than X. Number of the values less than X divided by the total number of the observation, the total, okay, total number of data values. Okay, that could be the case. It's usually a decimal number, so we multiply by 100, to make it into a whole number, if you like. Okay, so as soon as you find it, then you can multiply by, okay, you can multiply this one by 100. Okay, the result is going to be a decimal number. You can round it if you like. In some cases, they don't round it. But the way we do it, if you end up with the 20, in your book, I think, if you end up with the 25, they keep it. Otherwise, they round it. But it doesn't matter. It's not a big deal, really. You can round it to the next whole number all the time. This is one. The other one is in most of the statistic books, other than yours, when they find these numbers, they add plus 0.5 here. That gives a number which is going to be closer to the actual one. But in your book, they don't use it. So if you see this formula in any other statistic book, and on the top, there is a plus 0.5, then don't be surprised, okay? But I follow your book. My notes, I have a 0.5 here, but since we want to know, follow your book, so we don't add it, okay? So that's going to be the case that you have to consider. That's it. This is going to be the formula that we are going to have in order to get the K. Okay, any question? Let's have one example to see what we're going to do it. You get quite a lot in your book for your assignments. So we would like to find the percentile. The value would be given to the percentile of a score. Okay, score 12. This is a score from a test, the test with the 20 points in the following. Okay, in the following data set. Suppose I give you a quiz with, with 20 points, and then these are the results. You get 12 in that test, so you want to know what is your position in the class. Okay, so this is the idea of this problem. Okay, so the numbers are 18, okay, 18, 15, 18, 15, 12, 6, 8, 2, 3, 5, 20, and 10. So these are the result of the test, and you got 12. You want to know what's going to be your position. First thing to do, you have to order this set from the smaller one to the bigger one, okay? So the solution is going to be, so we're going to order, okay, order the data set. From the smaller one to the bigger one, the smallest one is going to be 2. You see, that's going to be the 2. Then you get the 3. Okay, 2, 3, then you get the 5. Okay, 5, then we have 6. Okay, then you have 8. 8. The next number is going to be 10. Okay, 10, 12, 12, 15, 15, 18, and 20. So this is how we order the set. Any question? So write your formula. So the value in question is, you count the number of the observation that we have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is equal to, okay, n is equal to 10. The number in question is 12. So you want to find the ranking of the 12. So repeat the formula, see k is equal to, and just repeat it again. In this case, you have to count how many numbers do you have? Number of, okay, the number of values. Number of the values less than 12 divided by total number, total data values. So k is equal to, so we start counting. You see, this is the 12. You count 1, 2, 3, 4, 5, 6. So 6 numbers less than 12. So the top would be 6. Okay, the bottom one, the total number of observation is 10. 10. I told you it's a decimal number. You can add, multiply the 100 here, or just do it yourself, okay? And so this is going to be the case, and you multiply by 100. So that gives 600 over 10, which is going to be 60. So k is equal to the 60. So this is going to be the percentile of 12. So the way we are going to write it down, we write the p of 60 is equal to 12. So this means if you get 12 on that test, you are better than 60% of the population of the class, but there are 40% of the grades above your grade. Okay, so that give you your ranking or your position in the, in the class. Any question? It's very easy to do. If you do with the 0.5 that I talk about it, the result would be 65%, but we follow your book. So this is it. So P60 equal to 12. Any question? So that would be very easy to do it. Okay, that's a part one of that problem. So in part one, in your book, they give you all these and ask you to identify the percentile of all of them. So we just check all of them, but on the test, we just give you a couple of them. So that's it, the direct problem. The direct problem is that the data values X would be given, and you are going to find the K. But there is a converse to this one, which is a more involved. The converse is going to be the other way around. We give you the K, the ranking. The ranking would be given, then you have to give us the X. Okay, just make sure you know the difference between the case one and the case two. Okay, so this time he's going to be finding the data values X when the K is given to you. Okay, so that's our second problem. So the second problem is going to be finding, finding the value X with the given percentile, okay, of the given K percentile. So the K is given to you. You want to find the X. That's more interesting. Now what we are going to do is we list the information first, okay, list the data values. So what we do, we have to find the location of the X first. We call it location number. We find the location of the number, and then we go to the set, and we are going to find it. So in order to get that location, we are going to introduce something that we call it the location number. Okay, it's kind of reverse formula or the converse to the other one that we did. So this is how we're going to do it. First case, as usual, you have to order the data values. Okay, order the data set as usual. You order it from a smaller one to the bigger one. Now the big one is this part, number two. Number two, you have to find the location of the value. So you find the location. Okay, location of the value X, which is missing, using this formula. The formula is going to be, you see, this is going to be L for location. We call it location number. This is going to be it's a K times N. Okay, K times N divided by 100. It's kind of converse to the other formula that we're going to have. So what is these terms that we use here? So this is going to be the case where you see this K is given ranking, would be given to you. Okay, so it's going to be given percentile. That would be given. N is the total number of the observation. Again, you are going to have it. Total number of observation or values. Okay, and you have to find the N. L is going to be location number. Location number. So you have to, you are going to bring this formula to your test, next test, and make sure you have you have the correct formula. Some people, they make a mistake on the test. As soon as they identify the L, they don't continue. Remember, this L is just the location of the X. is not the actual X. So what we're going to do when we find this number, there are two different cases. The case that the L is not a whole number and the case that the L is a whole number. If this is not going to be a whole number, we're going to round it up. Okay, you round it up. For example, if it's going to be something like 4.2, you round it up to the 5. Then you go to that list, order list that we talk about it. You see, you go to the order list of your values and you start counting. 1, 2, 3, 4, 5. When we get to the fifth position, the number in the fifth position is X, and then you're done. Okay, so the case one, if this is not going to be a whole number, round it up, change it to the whole number. Then you go to your order list and start from the beginning, okay, and count 1, 2, 3, 4, 5, 6, or 5, whatever it is. You get to that rounding numbers, and that would be your X. That's the case one. Case two is more involved. Case two, if this is a whole number. Suppose L is equal to 12. So what you have to do is, you have to go back to that order set. You identify the numbers at the 12 position and the next one, 12 and 13. Then you are going to find the average between these two to give you the value of the X. Let me write it down, then discuss it if you have question. So we find the L, so two cases. Case one. Case one, if this L is not a whole number. Okay, if L is not a whole number, it's not going to be a whole number. Round it up. Round it up. Okay, round it up. Even if it's 4.1, you are going to call it 5. Okay, if L is not a whole number, round it up to the next whole number. To the next whole number. So that would be the position of the X. Go back to that order list and pick the X. So we're going to select. Okay, select the data value X, the data value X, okay, in the order list. Okay, select the data value X in the ordered list, and that is corresponded, that is correspondent to the rounded up number. Okay, to rounded up number L. Okay, so that's going to be case one. Okay, the number is not the whole number. You change it to the whole number, and then you go to the list and you pick it. That gives you the position. You identify what value is going to be on that position. Okay, that's case one. Any question? Let's get case two. Case two is a little bit more involved when it is a whole number. Okay, so if L is a whole number, it's always like one next. Okay, if this is a whole number, you are going to use the value. Use the value X. Halfway means in the middle. Okay, halfway between those two positions that you have, the position of the L's and the position of L plus 1. Okay, so if you get a 4, then you go to the list, you pick the number at the 4th position and the number at the 5th position. Then you find the average. You add them together and you divide by 2 to get these numbers. Okay, so if L is a whole number, use the value X halfway between the L and the L plus 1. Then, when you just starting, counting from the order list. Okay, counting up. Okay, counting up from the lowest value to the highest. From the lowest value, this means in the order set. Okay, to the from the lowest value, okay, in the in the order set. I already explained that, but in the ordered set. So basically, this would that will happen. You see, this is L position. You pick a number in this position. This is going to be X1. You get the L plus 1. You pick a number over here, which is going to be X2. Okay, then your X would be the average of the X1 plus X2. X1 plus X2 divided by 2. Okay, so that gives you the data value X that we have. Right on, we're going to check it by one example to see how we are going to do it. Okay, and the expression is, any question? Let's check it by example to see. We give you one question, just a couple of numbers that you have to check for us. Okay, so there you are. Some of them that you're going to use in future, like the Q1, Q2, and Q3, we are going to have a shortcut for it. But we give you one on the next quiz that the percentage is going to be different. So you have to know this method. Okay. So what's going to be the example? Example, I'm going to use the same data set that I talk about it for this one. So this is it. Suppose you have the following. You see the data set. The data set is given as follows. It's given as the following. Again, I just listed because we already got this one, 2, 3, 5, 6, 8, 10, 12, 15, 18, and 20. It's already been ordered. So what we'd like you to do, we'd like to find the following for us. Okay, find the data values or the values. Find the values that corresponds that can be corresponds to the following. P70 means the ranking is 70, K70. P75 and P80. So the ranking is given to you. See the rank K is equal to the 70 here, K equal to the 35, 75, and the K equal to the 80. So we want to find the values, the numbers. Okay, there you are. For each one of them, you have to get the location number. So the set must be ordered. It's already ordered, but I write it down so you know that you have to check it. So the first thing to do is you have to order the data set because you need it in order. So it's already been ordered. So I just repeat it. It's going to be 2, 3, 2, 3, 5, 6, 8, 10, 12, 15, 18, and 20. So it's already been nicely ordered. Otherwise, you have to do it. Okay, let's do P70. You want to find the numbers that correspond to this position. So since it's a P70, this means K is given to you. K is 70. And the number of the observation is 10 because you have 10 numbers here. Okay, so the location number, X is missing, so we have to find the location number, okay? So X is missing, so we have to find the L first. Okay, get the formula for the L. L is equal to the K times N over 100. Substitute K is going to be 70, N is 10 over 100, so that gives us 700 over 100, which is 7. So L is equal to the 7. L is 7 is a whole number. Okay, since it's whole number, so what you have to do, you have to consider the L, which is equal to the 7, and you have to consider L plus 1, which is equal to the 8. Okay, so you go to the set and identify what number is in this position. The 7. You see 1, 2, 3, 4, 5, 6, 7. So the number in this position, I call it X1, is 12. Then on the 8, so that's going to be 15. So your X2 is equal to the 15. Okay, so your number is going to be X, is going to be the average. X is going to be X1 plus X2 divided by 2. So in this case, it's going to be 12 and 15 divided by 2, that gives you 27. 27 over 2, which is 13.5. So P70 is going to be 13.5. So this means 13.5 is on the 17 okay, percentile. So if you get 13.5, you are better than 70% of the class. Any question? So it's compared to L. You see L is equal to the 7. When it's a whole number, you go up one step. You see, make it the 7 and the 8. So you find the numbers at the location, the 7th location and the 8th location. Then you get the average of these two numbers that give you the result, 13.5. Okay, so that was the case 1. Any question? Let's check the next one, P75, to see if you get something different. Are you ready? P75. P75, the ranking is 75. So we would like to get the P75. So in this case, this means the K is 75. N is 10. So you have to find the L. Okay, L, location number. So the formula L is equal to the K times N divided by 100. So that gives us 75 times 10 divided by 100. So that would be 750 divided by 100. You know that is going to be 7.5. 7.5. So L equal to the 7.5, you see, is not a whole number. It's not a whole number. So what you're going to do, you're going to round it up. This is 7.5. So it's going to be approximately 8. Okay. So it's going to be approximately 8. So you go back to your list and check the number at this position, at the 8th position. Okay. So this is it. This is your list, and that's going to be 1, 2, 3, 4, 5, 6, 7, 8. So the number is going to be 15. Okay, so this means X is equal to the 15. So a P of 75 is equal to the 50. It's a third quartile. We have a shortcut for this one, but We talk about it later. Okay. So that was the P of P75. Any question? Let's check P80 again. That would be a whole number. So we want to check, make sure we have no difficulty for that. Okay, so again, the ranking is equal to the 80. The number of the observation is 10. So we are looking for the location number. Okay, so the location formula is K times N over 100. Substitute. K equal to the 80, N equal to the 10. So that gives 80 times it by 10 over 100. So it's going to be 800 and 100. That gives 8. See, 8 is a whole number. Okay, this is a whole number. Is a whole number. So you have to go to that halfway that we talk about it, okay? So this is going to be the case. Your L is equal to the 8. So you have to consider L plus 1, which is going to be equal to the 9. You go to the list and you pick these two numbers. Okay, at the 8th position, the number is 15. Okay, and at the 9th position, the number is going to be 18. Okay, 18 and 19. These are going to be your x1 and the x2, if you like. So you are going to find the x. X is equal to the 15 plus 18 divided by 2. So that will give us 33 over 2. Okay, 33 over 2, which is going to be 16.5. So P of 80 is going to be 16.5. Okay, so it's not a difficult procedure really to get this number right away. Any question? So this is where the ranking is given to, then you are going to find the values. There is a special case that we're going to use. You have to know this one, but for any other purposes, when we want to use this idea, we are going to be really interested in those quartiles only. Remember Q1, that is the first quartile, Q2 is 50% or just a median, and the Q3 is going to be the third quartile. So I'm going to give you a shortcut for that one, and then we do a break, we come back and we see the application. Okay, any question? So for the next problem, you can also use this formula, but it's much easier to do it right away. Okay, so this is it, example. Very nice method. Okay, suppose you want to find the Q1. You must know the meaning of the Q1, Q2, Q3 or so. Okay, we want to find the Q1, Q2, and Q3. And Q3 for the data set. For the data set. And this is the set. The numbers are 15, 13, 15, 13, 6, 6, 5. Okay, that's a 6, 5, 12, 50, 22, and 18. You see, we want to find only those quartile, if you like, to get this number. Now, the shortcut is, you know that the median, Q2 is the median. The median is very easy to find. So what we're going to do, as we did it before, we are going to order it first, and we check the Q2 first. Okay, so the solution is going to be, you are going to order this set, order the data set. So order it, start from the smaller one to the bigger one. So the smallest number that we have is going to be 5. Okay, so this is going to be 5. Then we get the 6, 5, 6. Then the next number is going to be 12. Okay, 12, 13, 15. Okay, 15, and the rest are going to be what? You get the 18 here, 18, 22, and 50. And we want to find the median first. You know that 50% to the right, 50% to the left. You count the number of observations that we have, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So n equal to the 8, which is an even number. So to get the median or Q2, it's 8. 4 to the right, 4 to the left. You see 1, 2, 3, 4. 1, 2, 3, 4. You see nothing in the middle, and this is Q2. So what you do, remember, when we get even number, we have to find the average of those two central elements. So this is going to be 13 plus 15 divided by 2. That gives you 28 over 2, which is equal to the 40. Any question? So we find the median first. You see that 25% and 75% that we talk about it. You see, if you just consider the numbers to the left of the, okay, to the left of the mean, these numbers, your Q1 is going to be the center of this, that 25% that we talk about it. So what we're going to do is we are going to consider the number to the left. There are 4 numbers, so there's going to be 1, 2. You repeat that procedure again, 1, 2. So the one in the middle must be Q1. So the Q1 is going to be 6 plus 12 divided by 2. 18 divided by 2, that gives me 9. Okay, so you go to the left and the right. If you go to the left and do the same thing, that gives you Q1. And if you go to the other way around, you see 1, 2 again, 1, 2, 1, 2. So nothing in the middle. So this is going to be your Q3. So the Q3 is going to be, you add 2 central one, that's going to be 18 plus 22 divided by 2. So that gives you 40 divided by 2, which is equal to 20. So in this case, Q3 is equal to 20. You can use the other method that we talk about it, but this is much, much easier. And for these cases, you know, we are just using this method quickly. Okay, so you have to identify the median first. You identify the median first, you go to the left, the leftover, if you like. The leftover, we can the median that give you 25% of, or the general one. Okay. So in this case, it's 6 and 12, 18 over 2, which is equal to 9. And we do the same thing to the right. To the right, you find the center, and that give you your Q3 that we're going to. Okay, so this is how we're going to find these numbers. Any question? So let's have the break and we come back, and there is another application that we are going to use it. One is when the setup numbers are given to you, we already talked about it. Sometimes we get a number, we used to call it very extreme, okay, or extreme, which is going to be sometimes very large when you compare it with the other one, and sometimes very small. So sometimes these numbers are going to be called outliers. So we're going to tell you from a statistical point of view what the outlier is and how you're going to find it. And then there is something else, you know, we try to see if we can finish it. So that was the first part. And that's it, it's 11:14, 10 minutes. We come back 11:24 and we try to finish it. See you then. Okay. So we are going to continue a couple of more terms that we're going to define. Okay, so this is how we're going to find Q1, Q2, and Q3. So from time to time, when the set of data would be given to you, you may see some strange numbers. Sometimes you may make a mistake when you want to type the numbers, or if you do some experimental work, in physics, chemistry, sometimes it's something may goes wrong, if you like. So you get these type of values that we're going to call them outliers. So there is one way to introduce these so-called outliers, and this is going to be your job. A data set would be given to you, then you should be able to identify the outlier for us, okay? So I'm going to define it. We are going to define a range, statistically, that we are going to call it a safe zone, if you like. So if your numbers are going to be in that interval that we're going to introduce, so the numbers are going to be okay. But if it's going to be anything outside that special interval, those numbers are going to be outliers, okay? So we're going to introduce those as formulas, and then we determine whether we get outliers or not, okay? So this is going to be, we call it checking for outliers. So there's going to be a type of one question that you find this Q1, Q2, and Q3, and you check for the outliers. So that's it. We are in that section 3.3. It's a very long section. So checking for outliers. Okay, outliers. That's it. Now to create that interval, suppose a data set is given, okay, and you are able to find the Q1, Q2, and the Q3. So suppose Q1, Q2, and Q3. Okay, of a given data set. Okay, these numbers are given to you, if you like, okay? So suppose Q1, Q3 of a data set are given, or you have to find it. This is going to be the one. And there is going to be a special number that we are going to consider even in the next section. So we introduce that one first. This number for any data in statistics is going to be called, what is the okay, what's going to be interquartile range, we call it. Interquartile range, or the expression on the calculator or in general is this, IQR. So if you see IQR, this means the interquartile range. And this is only the difference between the Q3 and the Q1. Okay, so the interquartile or IQR of a data set, okay, of a data set is going to be defined by, this is it, make sure you get the writing done correctly. IQR is equal to, is going to be equal to the difference between the Q3 and the Q1. Okay, so those numbers that we did talk about it. So if this is going to be the Q1 and this is going to be Q2, and then you have a Q3. So this range, if you like, okay, so this range on the top, the difference is, this range is going to be your IQR. Okay, interquartile sign. So this is going to be the range that you see, this is going to be 25% and this is 25%. So in between, this is going to be kind of okay, kind of 50%. So that QR give you a measurements. They call it the middle 50% of the observation. Now, the data sets given to you identify the IQR, then we can define the range, the possible range, or where the data values are going to be considered to be not outliers. This range would have a lower bound and the upper bound. They call it fences. So the other expression is the fence or fences of a, we're going to make a zoom if you like. So the fences of a data set are going to be defined by, and there is going to be a lower fence or the lower end, okay, lower value if you like. So that's going to be lower fence. Usually refer to it as your calculator is going to be LF. Okay, lower fence is going to be equal to the Q1 minus 1.5 times IQR. Make sure again write the correct formula. This is a kind of lower bound for the interval for the values. And there's going to be upper one, upper fence, denoted by UF. And this is going to be Q3 plus 1.5 IQR. Okay, so you already got the Q1 and the Q2. Find the difference that give you IQR. You substitute here, that give you an interval. So you identify this interval. So for your interval, you start with the lower fence. It's going to be your lower fence. And you end up with the upper fence. So this is going to be the upper fence. Okay. If the numbers are going to be inside these fences, okay, this interval, the numbers are fine. But if you get anything outside, you see if you get anything outside here, or if you get a value which is going to be outside here, those values considered to be outliers. Okay, so anything here is going to be outliers. But if you get something here, this would be outliers. Okay, so you get these numbers and you already got your list, your data list, and you compare it together. If there is going to be a number left over, if you like, to the left or to the right, that leftover is going to be your outliers. Okay, so this is how we're going to define it. So we give an example to find it. Any question? So this is going to be, definition of the outliers. So we have to give you 2 examples, and this is the way we are going to ask you a question on the next quiz. It's going to be used in one more place, but usually if you want to give you one question for all of them would be too many. Okay, that's why we break it into different parts. So this is the example, very standard one. We wanted to check, okay, this is it. We wanted to check for outliers. Okay, check each data set, okay, for outliers, Okay, we check for outliers and we're going to give it 2. And so the first one, the numbers are 16, 18, 22, 19, 3, 21, 17, and 20. You see, when you look at the numbers, You see the numbers are almost close to each other, but suddenly you get 3 here. So this 3 seems to be an outlier. So if you do some experimental work and suddenly you get the 3, you have to think about it. Maybe you made a mistake. You see it was some reading in for chemistry. So you just think about it now. You have to double check it. But you have to prove it statistically. Don't say that, oh, I can see the 3 is an outlier. No, you have to prove that this is going to be outlier, okay? So this one set, give you another one. This next one is a 14, 16, 14, 16, 27, 18, 13, 19, okay, 36, and the 15 and 20. Again, for the second one, you may have some doubt about 36. That it may be an outlier, but you have to check it to see if this is going to be the case. Okay, are you ready? I do the first one myself and ask you to do the second one yourself to see if you can do it. Okay, so there you are. Solution. I do the part 1. So you have to order the sets. You find the Q1, Q2, and Q3. We need the Q1 and the Q3, of course. Okay, so the first thing to do, order the data set. That's it. Smallest value is 3. So that would be 3. Then you go to the next number, which is going to be 16. Okay, that's going to be 16, 17. Okay, and you continue, we get the 18. You see 18, 19, 20. Okay, 20, 21, and 22. So this is going to be the way we're going to order it. And the number of observations is going to be 1, 2, 3, 4, 5, 6, 7, 8. So n is equal to the 8, which is even. So 50% to the right, to the left. 1, 2, 3, 4. 1, 2, 3, 4. You don't need the Q too bad, you know, you have to separate it. So that gives you Q2, which is 18 plus 19 divided by 2 is 18.5. You go to the left and the right, that gives you Q1 and the Q3. Okay, to the left of the 18.5, you get 1, 2, 3, 4. So 2 to the right, 2 to the left. So that should give you Q1. You add. If it's an odd number, you will see it right away, but it's not odd. So it's going to be 16, 17 divided by 2. So that would be 33 divided by 2, 16.5. So that gives us a Q1. Of course, calculator can give you this result as well. You can do that. So to the right, 1, 2, 1, 2. So that gives you Q3, which is going to be 20 plus 21 divided by 2. Okay, that would be 41 over 2, which is 20.5. So that's it. You have your Q1, which is equal to the 16.5, and the Q3, which is equal to the 20.5. You don't need the Q2. Any question? So continue, you have to get the IQR. The IQR is the difference between Q3 minus Q1. Then you can find the lower fence and the upper fence to compare, okay? So we go on, IQR. It's a difference of the Q3 and the Q1. So that would be 20.5 minus 16.5, that give you 4. So IQR is equal to 4. That's IQR. Again, make sure you get your formula all right. And again, if you substitute this information in your calculator, as we did it the other day, that give you all these numbers quickly. It's not a big deal. So we go for the lower fence and the upper fence. Okay, this is it, lower fence. Lower one is Q1 minus 1.5 IQR. So it's going to be 16.5. 16.5 minus 1.5 times the IQR of the 4. 1.5 times 4 would be 6. So 16.5 minus 6. Okay, so that gives a 10.5. That's going to be the lower bound, if you like, of your information. Then you check the upper fence. The upper fence is going to be Q3. Remember, that's a Q1, the other one is Q3. Q3 plus 1.5 IQR. Your Q3 is 20.5. 20.5 plus, we already did this one, so it's going to be plus 6, which is 26 point. Okay, so that gives you 26.5. 26.5. Okay, there you are. If you put these numbers, so your fence start from 10.5 going to the 26.5. Okay, that's your lower fence and the upper fence. But the numbers that you have, your values start with 3. You see 3, 16, 17, etc. So as you can see, your 3 would be here. So this is going to be 3. Okay, this is going to be 3, and the rest are going to be inside. You see, it's going to be 16. And you go up to the what? Your number, last number is 22. So as you can see, 3 is going to be the leftover, because these are going to be your outliers. Anything in this interval are going to be outliers. So 3 is an outlier. Any question? So you just identify the possible range. The possible range starts from 10.5 to the 26.5. But your number starts from 3. You see, you have the 3, 16, the next number 17, etc. But the 3 is going to be the leftover outside in this region. So 3 is going to be an outlier. Anything else is inside. So this means 3 is going to be an outlier, and your data set would have an outlier. Any question? So this one is consistent with, when you look at it, it's going to be the same thing. But as I told you, you have to prove it. You have to get these numbers down. Okay, that's the first part. Any question? The second part is similar. Let's do it. And you shouldn't get any outlier for this one. Let's see if this is going to be the case. Okay, again, be careful regarding the formula, really. Otherwise, it's easy. I'm going to do it because I want to make sure that I get time to finish it. There's something else that we have to talk about if we can. Okay, part B, order the set. That's it, order the data set again. And if you order it, start from the 13. This is going to be 13, 14, 13, 14, 15, 16, 18, 19, 20, 27, and the 36. See if we get those numbers done. If you count the number of observation, we get 9 this time. 1, 2, 3, 4, 5, 6, 7, 8, 9. So n is equal to the 9, and 9 is an odd number. So 50% to the right, to the left, that gives you 4.5. So this is going to be the case. 1, 2, 3, 4. 1, 2, 3, 4. So we get the leftover here, which is going to be your Q2, which is 18. Okay. We got the 9 elements, so it's an odd number. So the middle one is possible. So you get the numbers to the left of the mean and the right of the mean. The left of the mean, we get these numbers. We get 4. So it's going to be 1, 2, 1, 2. Remember, it's the left. You are not going to consider 18 anymore. To the left of the mean and to the right of the mean, the median. In case you are going to have the Q1, we have to add 14 and 15 divided by 2. So that would be 29 divided by 2, which is a 14.5 for the Q1. And we do the same here. That's going to be 2, 2. So that gives us a Q3, which is 20 plus 27 divided by 2. 47 divided by 2. Okay, which make it into 23.5. So that would be 23.5. Okay, so we got the Q1 equal to the 14.5. And we have the Q3. You don't need the Q2. Q3, which is 23.5. Okay, go ahead and get the IQR. Okay, so we are going to get what is going to be the IQR. IQR is going to be Q3 minus Q1. Okay, Q3 is 23.5 minus 14.5. Okay, and that is going to be 9. So the IQR is going to be 9. So go for the lower fence. The lower fence is equal to the Q1 minus 1.5 IQR. Okay, so Q1 is 14.5 minus 1.5 times IQR, which is 9. Okay, so this is going to be 14.5 minus 9 times 1.5 would be 13.5. So the IQR would be 1. Sorry, lower fence would be 1. Okay, so there's a lower fence, find the upper fence. So the upper fence is going to be Q3. Okay, Q3 plus 1.5 IQR. So the Q3 is 23.5. 23.5 plus 1.5 IQR is 13.5 that you got here. And if you add them together, what's that? So 5 and a 5 would be 10. Okay, that would be 37. Very close. Because the number that you have is 36. That you may think that this is going to be an outlier, but it's not. Okay, so your zoom are going to be zoom. Let's see, this is the one. So the least number that we have, the lower fence is going to be equal to the 1, and the upper fence is equal to the 37. Okay, so if anything outside is going to be the outliers. These are going to be the outliers. But your number, you see, the minimum that you have is 13, and the maximum that you have is a 36. So this means your 13 is going to be inside here. Okay, and the 36 is going to be inside here again. So you have nothing left, if you like. Okay, so there is no outlier. There is no outlier. Okay, so you have to check it, you have to test it to see if this is going to be the case. So for the other one, 3 was seems to be, we just have a look and we find out that this 36 is very, very close. So you have to check it to get these numbers, and on the test, this is the way you're going to do it, okay? Again, the calculator will do it for you. But you have to, to submit all those information in it. But Q1, Q2 can be easily found. You can use those, we don't mind if you want. All the information can get it quickly. Even those easy calculator, just those scientific one also give you this information, okay? It's not a big deal, we can find it as well. That makes you get the idea. Okay, any question? Now, there is one more thing to finish this section and this part of the course, okay? All these formulas, numbers. You see this last one is, we already talked about graphing, okay? Graphing the information. We talk about histogram, relative frequency, the charts, the pie chart, pie chart, etc. But in practice, if you have a limited number of information or the finite number of the information, something like if you have 5 numbers or even up to the 20 numbers, there is another way using this type of ideas to represent or to graph the information. This is very popular. All the calculators will do it for you. This is going to be called the box plot. The result, the graph is going to be box plot. It's going to be a box that would be involved with these 3 numbers, the Q1, Q2, and the Q3, okay, all together. And that is going to be called the box plot. It's very, very easy to construct and very easy to get the information from it. Okay, so I'm going to write it down for you, but I just want to give you an idea of just quick idea what is going to be the box plot involved. You see, for example, if you consider this information that we have here, you see, because for the box plot we have to find the Q1, Q2, Q3. So the way we can do it is just a preview for the, that's it, box plots. I'm going to write down a full detail. Let's give you an idea first. You see, for the box plot, we are going to use 5 numbers. The numbers are going to be the following. And the numbers are going to be the least numbers, minimum, Q1, Q2, Q3, and the maximum. So you have to find these 5 numbers. We call it 5 summary numbers. As soon as you find these 5 numbers, you are going to put them on the number line. You see, this is going to be the number line. So you identify somewhere, somewhere this is going to be the minimum. Suppose this is going to be the Q1, this is going to be Q2, and this is going to be your Q3, and you get the maximum. You get the maximum. Okay, then what we do is, you see, this number is going to be on number line. We are going to above it, just identify by a line that this is where the minimum is. This is the Q1, Q2, and the Q3, and the maximum. Okay. Then we connect these bars of the Q1, Q2, Q3 to make a box. You see, that's going to be the box. Then we connect the box to the mean and the maximum. That's it. This is called box plot. And the calculator will do it for you. some calculators, they are not going to do it horizontally. They do it, vertically. This is going to be how you can see it with your calculator. Okay, so it's very easy to construct, and especially it's going to be useful if you have a couple of not just a single data set. If you have two data sets, you're running your company and you have two different production line of the production, you want to compare them quickly together, then this is going to be very, very popular and very, very famous. And there is going to be how we're going to conclude that we are going to explain. Okay, so that's the idea. I quickly give you the names for these fives. So your job is going to be clear. You have to find these 5 summary numbers, we call them. You put it on the number line, get the box, and then you have to explain it for us. What happened to the distribution? Is it a usual distribution? If it's going to be a standard one, 50% right, 50% to the left. Otherwise, we say that your distribution is going to be skewed. So let me see how far I can give you those explanations. But otherwise, this is all you have. And of course, we give you one of them in your next, next quiz and the test. And sometimes we even repeat it on the final. This is the only thing that we give you on the final exam from the first part of the course, because we want to remind you that this is important, important graph. But otherwise, that's it. Okay, so let me just describe it for you quickly if we can. And we may give you example next time if we may be able to finish it. So what is the box plot? The idea, as I told you, if we have then the data set, when the data set contains only not many numbers, of course, just small numbers, contains a small number of values. Okay, 5, 10, 20, 25. If this is going to be the case, now then a box plot. That is the expression box plot. The box plot is used. It's used to graphically, if you like, represent the data set. Okay, so it's used when the number of the observations are finite. Now, as I talk about it, it's involve 5 numbers. So you got to know these expressions because they ask you. So the box plot involve 5 numbers. 5, let's say a specific number. Specific numbers that we refer to them called a 5-number summary. A 5-number summary. That's the expression that you use in your book. Okay, or in short, 5-number summary. Okay, 5-number summary of the data set. So the numbers, as I talk about it, are going to be, the first one is the lowest value or the minimum, the lowest value of the data set or mean. To show it by the mean, if you use your calculator. That's the first number. The second number is Q1. The third number is Q2. The fourth number is Q3. We need all the three. That's why we give you that shortcut. And the 5 number is the maximum, the fifth one. Okay, so this is going to be the maximum, the highest value or largest. So this is going to be the highest value of the data set, or the maximum. So we have to find these numbers. Then we can construct the box as I did it. You identify these 5 numbers on the x-axis and you get those bars on the top, and just to do it. So this is it, briefly explaining to construct a box plot. This is what we're going to do. The first part, you have to determine the 5 number summary. Determine at 5 number summary first. That would be 50% of the grade. So make sure you don't miss it. So that's the first one. So again, you are going to draw a horizontal. I go with the horizontal line. You see, if your calculator, that's going to be vertical, we don't mind, even if you want to do it on the test. But I do the horizontal one. That's why I say draw a horizontal. Okay, draw a horizontal axis, like the x-axis, on which you locate those numbers, on which the 5 numbers, 5 number summary can be located. Okay, that's one. So you make a box using the chordals. Okay. So, if you want more information, we are going to mark this information by a vertical line above it. Okay, mark the quartiles and the mean and the max, and the mean and the max with vertical lines. Okay, with vertical lines above that x-axis, vertical lines. That's it, and then connect those chordals together, the chordals, to get the box. Okay, to make a box. So the box would be a connection between Q1, Q2, and the Q3. Okay, now go to the box and connect it, and then so you are going to connect the box to the max and the min. Okay, to the minimum and the maximum, and the max with lines. That's it. This is how we're going to make that box for you. Okay, if you want, I give you another one here. That's the minimum. You get the line on the top. That's a Q1. You get the line on the top. Suppose this is the Q2. You get the line on the top. And suppose this is Q3, the line on the top. So you are going to get the box by connecting these Q's together. And this is going to be your maximum. So you connect the box to the max and the mean. There you are. So this would represent the Q1, Q2, and Q3. And this is the mean, and this is the max. It would be very easy to, to put them together. Those outliers, everything, you can check it with this one too, but you have to use the same formula that we talk about it. So that's why I take them out. So if we give you a question on the test, we give you the question, one question on the test, we just ask you to construct the box. Okay, in your book, as they ask you to construct the box, sometimes check for they ask for the IQR and checking for the outliers, but we break it into two problems because it would be too much to be able, or to be asked to do all of them at the same time. Now, what are going to get the conclusion from the box? Okay, over here. So the conclusion from the reading from the box is going to be, you see, when you construct the box, Q2 is going to be the center of your information because it's the median. But this box would have a natural center. The natural center of the box is going to be, for example, here. You see, that's going to be the middle of the box. And this is going to be the middle of your information. So the connection between these two are going to be the one that you are going to make a conclusion. You see, if the Q2, which is the center of your data set, and this red one, which is the center of the box, are close to each other, so this means your data set is symmetric. It's very fair one, because your information is 50% to the right, 50% to the left. So if I give you a nice test, a fair test, the box plot for that test must be that this red and the green one must be close to each other. Otherwise, you may get the red to be, you may get your center to be above the red one, above the center of the box, or maybe below. Means you are going to have a shifting, if you like. Your information may be shift to the right or shift to the left. We don't usually say shifted. We say it's skewed to the right or skewed to the left. So when you construct your box, you have to explain it for us, which one is it? Okay, it's going to be 3 cases that we are going to have, Let me see if I can write this information too for you, and then we give you example next time. So you construct it, but you have to make a comment, okay? So your comment coming from this information. So that would be information obtained from the box. Obtained from a box plot, Okay, there are 3 cases. Case 1. We compare the center of the C if the median, your median of your data, median Q2 is near the center of the box, means the natural median, the center of the box, sorry, center of the box, then we say the distribution is symmetric. That's the best case. Distribution is, let's say, approximately or just it is approximately symmetric. So this means your information is very usual one, regular one for your test, your set. because it's a 50% to the right, 50% to the left. So this is going to be your box in this case. You see that's a box that we're going to have. There is a center of the box. You see the actual center of the box. This is going to be the center of the box. And your center is very close to the box. You see that's going to be the one. So in this case, this is going to be the case that they call it symmetric. Symmetric distribution, if you like. Symmetric distribution. So when I use this red one, you have to do it on the test, the red one. And this is going to be center of the box. Okay, center of the box. And the green one that I use, this is going to be the center of the data set, which is Q2. Okay, so we compare them together, two different centers. Okay, so you will see it. You can prove it mathematically because you see, remember this is the Q1 and this is the Q3. If you subtracted that, give IQR, which is this line. If you divide it by 2, that gives you the center of the box. So you have the center of the box and you have the Q2, you can compare them together. So if sometimes, it's going to be very close or you have any doubt about it, you can find it to get this, this idea, okay? So Q3 minus Q1 would be IQR. You divide it by 2, that gives you the center of the box. And you already got the center of your information. It's not a big deal. All of them are clearly, it's easy to identify. Okay, any question? Let's get the second case. So if they are not going to be close to each other. So if the median, if there's going to be a shifting, if the median of your information Q2 falls to the left, shifting to the left of the, okay, to the left of the center. If this is going to be the case, center of the box, we say that the distribution is not symmetric, it's skewed. The distribution is, okay, is positively skewed. You get a shifting to the left, it's like a function. Shifting to the left is towards the negative one, but it's going to be called positively skewed. So this is again the box. This is the box, and this is the actual center of the box. But in this case, you are here. You see? So this is going to be your, this is going to be your Q2. So as you can see, your distribution is not going to be, in this case, said it, is positively skewed distribution. Okay, so sometimes it's going to be a good thing or sometimes it's going to be a bad thing, depends on what you want to know, what you want to do. If it's going to be a result of the test, it may be good for you or maybe not. Okay, and the case 3 is the other way around. If the median Q2 is going to be to the right. Okay, it falls to the right. To the right of the center of the center of the box. Again, it's skewed, shifted to the right. When shifted to the right, is skewed negatively. If this is going to be the case, the distribution, then the distribution is negatively skewed. Okay, so this is going to be the box. This is the actual center of the box. And you are here. So this is going to be Q2. Okay, so in this case, this is going to be negatively skewed. Negatively skewed distribution. We give you a real example next time, then we can talk about it to see what does it mean. Okay, so these are the three cases that you are going to have when you get this information. So you graph it and you make a comment for us, and then we're done. Your book, they like it very much. You have the number of the problems in your book, but you know, it's easy question. As I told you, from this part, the only question that I repeat on the final is this one, from everything you did so far, because this is important. Sometimes you need to know it, so we usually repeat this one on the final too, but otherwise, nothing else would be repeated. That's it. I give you an example. Next time we are done with this first part of the course, which is descriptive statistic. As I told you, we are going to be focusing on chapter 4. We do 3 sections of chapter 4. Is a notion of the probability. It's going to be very classic one. The classic probability is, gambling. That's going to be the one. Okay, but then we change it to the modern time notion of the function, and then things getting much easier and very interesting for the rest of the course. Okay, that's it. Any question? So study this one quickly, and then we continue next time, and I will grade your test. I post the result. After I posted, if you have any question, you let me know. That's it. Have a good one and take care.